ammeter, voltmeter, galvanometer work on the same principle internally. So it should be possible to convert one to the other. Now, in case of voltmeter, there is coil resistance, there is series resistance. And now we find that 12 volts is the maximum. Okay. Maximum means coil can take maximum current of 12 divided by 1.15 plus, or I can convert everything to ohm. Okay, let's convert everything to ohm. 1150 plus 50. So 12 upon 1200. That's the maximum current which can flow through the coil. And if you are using it as an ammeter, even then you can't violate this thing. So in that case, coil has to be the same. The resistance you can change. So you can remove that 1.15 kilo ohm, and in its place you can connect a shunt of some value. Here is that shunt resistor of some value. So this is 50, and this is shunt resistance. Total current that you want to measure is 2 amperes, and the coil can take this much, 12 upon 1200, which is 1 by 100, right? So 1 by 100. You know the formula for current distribution, right? For parallel resistors. So you should have no problem now in finding capital R. If the total is 2 and this fellow takes 1 by 100, 1 by 100. So can you find out capital R and let me know? Well, the answer I have is 0.251 ohm. Now, The basic instrument which is made in factory, that's same, but you will have to change that scale, right? When needle moves, so if it is written volt and some markings would be there, 5 volt, 10 volt, so it's not so simple that you do this type of thing and your voltmeter becomes ammeter. You will have to take care of the gradations here, and this V won't be V, it would become amperes. Alright, now an ideal voltmeter should have infinite resistance, but voltmeter's coil must have currents without which it cannot turn. And if the coil has infinite resistance, it can take no current. And if it can take no current, then how can it turn? So obviously, it's about compromise. You will accept that, okay, voltmeter is going to affect my circuit a bit, and I'm okay with it. Or you will intelligently choose your voltmeter, which does not significantly cause error to your experiment. But don't we have a better solution which gives us the ideal type of thing? The answer is yes, we do have something like that. And here comes potentiometer. So what is potentiometer? Potentiometer is something as simple as this. A straight wire with 2 points to connect here and there, and a movable point to connect. So such a simple thing is potentiometer. So obviously it is not going to replace the exact working of voltmeter, but it can be used in such a way that we get the result which an ideal voltmeter will give us. Right? So it is a simple resistor for thinking sake. A simple wire you can imagine, not ideal wire. It has some resistance per unit length, uniform, let's say, and 2 points fixed. 1 point you can slide. So if you connect your external circuit between these 2 points, then this length will participate in giving resistance value. But if you move it further here, then this length will participate. You can call this jockey. Jockey is something that you can move. So between this and this would be the resistance value if you choose to connect potentiometer across these 2 points. Well, you can also say I will connect it across these 2 points, and in which case the potentiometer will act just like a resistor with fixed resistance value. There are different ways you can connect it. Now, how to get the ideal, how to take the place of ideal voltmeter by using this apparatus? Suppose you have some resistor connected to some big circuit. Circuit I don't need to show. You need to visualize some big circuit connected here. You want to know potential difference across these 2 points without causing any change to the circuit. When you connect voltmeter, you know what happens. Voltmeter takes some current and that changes the internal characteristics of the circuit, at least to some extent. Now, instead of voltmeters, you are going to use the potentiometer like this. Here is your potentiometer wire, and maybe I can make it look somewhat thicker to differentiate from others. And then you have this point connected to this. Then source of EMF, and then you can have some switch here, some another resistance there. I'm not showing those things. Now, here for your experiment or your measurement sake, connect galvanometer. Galvanometer can take current in both directions. And then you have the jockey. J, that you can slide right or left. Alright. Others are ideal wires. Others are ideal wires. This is not ideal wire. Now, move your jockey in such a way that galvanometer shows no deflection. When galvanometer shows no deflection, then it means galvanometer has some resistance. It is showing no deflection means no current is flowing through it. A resistor, no current flowing through it only means that this point and this point are at the same potential. Okay? So if this is at some potential, it will be at the same potential. No current is flowing through this. Cut it. Now this battery cannot do anything to this part. Current requires a closed loop. You can't make a closed loop for that outer thing. Yes, here current will flow. Now, if the total potential difference across these 2 points is, let's say, V0, then, and also if the total length is capital L, total length is capital L. Now this when we talk about stretched wire potentiometer, that's what you will see in your physics lab. Wire, long wire. You will see the markings also, so that you can see the length. Potentiometers, all of them don't have to be stretched wires. But in the case of stretched wire, you can see the long wire and you can see the markings. So you can see this length. You can measure that length. Let's say that length is small l, from here to there. So this battery and this thing, that's it. Current is flowing like this only, as far as this battery is concerned. So for this battery, this resistor and this resistor, these two resistors are in series, right? And if two resistors are in series, then the potential drop across one resistor is proportional to the value of that resistor. And the value of that resistor is proportional to the length of the wire. That means if V is the potential difference, then V must be proportional to L. And V naught is of course proportional to capital L. What is it that you are trying to measure? This is ideal wire. If this is some potential same as this, what are you trying to measure here? Which physical quantity? V. From here to here, if it is V, from here to here also it is V. You are trying to measure V. L you have measured. Experimentally, capital L you know. The only problem is V naught. Now, we can divide these two equations. So we get V upon V naught equal to small l by capital L. Well, now you may say that V naught will be equal to E, or you may think like that. V naught may be equal to E. Now, battery will have some internal resistance, that is for sure. So whether I show another resistor here or I don't, there is surely a resistor here, the invisible resistor, small r, for the battery. And the current is flowing. If current is flowing, then potential difference across the battery is not equal to EMF for a real battery. So that's a problem. Even and if you have connected some resistance here, you may want to limit the current. So you may actually connect a resistance there. Well, and if you are using some unknown resistor, then you don't know V naught. So now how do we handle V naught? How do we handle V naught? The answer is that you take a standard cell. Standard means you know about it. You know its EMF. Take a standard cell, connect, remove this part and connect the cell in place of this part. Okay, connect the cell there. Cell has some EMF. let's say E. Again do the balancing, find out some point, maybe J dash, at which you find no deflection in the galvanometer. If you find no deflection in the galvanometer, it means no current is flowing, and this point are at the same potential. Now this circuit is gone, so this is not there, this is not there. In place of that resistor, only E is there. So this E cannot get current via some other loop. There is no other loop for E to get current. And if there is no current passing through the battery, then you know what is the potential difference across the battery? How much is it if no current passes through it? I repeat the question, when no current passes through the battery, what is the potential difference across the battery? E, EMF. You have not touched this battery, you have not touched whatever was here. If there was a resistor, don't touch it. So whatever was the V0 earlier, in the earlier part of the experiment, the same will be the V0 now. And what V was earlier, that V now is E. Jockey's position is J dash, length is L0. Let's say it is L0, which you will measure. L is L. So please note that the two V0s will be the same if you do not disturb this part of the circuit. If there was a resistor, it should be there, exactly just like that. Then if it was V0 before, now also it will be V0. Any questions up to this point, let me know. Well, now just divide these two and V0 won't trouble you anymore. You have V by E equal to small l by L0. That means V equal to E times L by L0. You can't replace voltmeter by potentiometer, but using potentiometer you have a procedure which can remove voltmeters use. And this procedure is a smart procedure because galvanometer has no current. Galvanometer has no current, and therefore if this does not have any current, this also does not have any current. That means you are not changing that external circuit at all. At balance condition, you are not changing external circuit parameters at all. Right? So let us take some problems based on potentiometer. The total length of the potentiometer wire is 40 centimeter. Where should the jockey be there? Or let's say, where should galvanometer touch AB so that the galvanometer may show zero deflection? Zero deflection. That means either you tell what is AJ or you tell what is BJ. But anyway, I'm going to do this one. When there is no deflection, these 2 points must be at the same potential. So does it not look like Wheatstone bridge? That means 8 ohm by 12 ohm should be equal to the ratio of the two resistors, but ratio of the two resistors is same as the ratio of the length AJ by DJ or JB. Now, can you do a little bit of mathematics, algebra, and find out the position of J? Well, you have not mentioned what is 16, AJ or BJ? AJ is 16 centimeters. Any questions regarding this? If you have, then let me know or we move on. Volt battery of negligible internal resistance. So let me write in bracket ideal. Is connected across uniform wire AB of length 100 centimeters. The positive terminal of another battery of EMF 4 volt and internal resistance 1 ohm is joined to point A as shown. Take the potential at B to be 0. Take VB equal to 0. I have written everything which were given in the question. So you should not need the words. This is ideal. This is internal resistance of 4 volt. VB is the reference potential. Total length is 100. What are the potentials at A and C? VA, VC. What are these? Okay, that's one question. Right now, jockey is not touching. So it should be very easy to answer this question. For example, if B is the reference and this is ideal, then what should be potential at A? Correct. Now, you are at 6. You have to reach here. First you find a fall, and then resistor will not be able to do anything because there is no current. So tell me, there is no current. So 1 ohm will be doing nothing. So what would be your answer? Ten versus 2. Let's see. There is a drop which is happening here. In other words, this point is at a lower potential than this point. Right side is at a lower potential than the left side. So if the left side is at 6, right side should be at a lower potential, 4 volt lower. Answer should be 2 volt. Now that was part A. Part B. At which point of the wire the potential is equal to potential at C? Nothing is touching. Which point on the wire, at which point on the wire the potential is equal to C? That should be very easy to answer. You want 2 volts here. B is the reference, 0 volt. A is at 6 volt. The 2 resistors, this and this, are in series. The potential drop is proportional to the resistance. So 6 minus 2, 4. That should be proportional to the resistance of AD. And resistance of AD is proportional to the length of AD. And likewise, this potential difference is proportional to its length, BD. You know the total length is 100 centimeters. From mathematics, algebra, simple algebra, can you find out the location of D? Divide the two and proceed. Let me check. That's right. So AD is 66.7, let's say, or BD is 33.3. So AB is our potentiometer, but really at this, up to this point of time, we have treated it as simple wire having some resistance. We have not even touched C to D. Now we are going to touch C with C to D, the same D that we found out here, 66.7. So now we are going to connect these two. What do you think? If we connect these two, will the current flow? Select yes or select no. Will the current flow? Yes, select yes or select no. You are saying current will flow. Let me say that that wire is not ideal. Galvanometer, let's say. Suppose you connect C and D by some galvanometer. Will it show any reading? If you connect 2 volt and 2 volt by some resistor, you're not going to get current. You're not going to get current. So the answer is no current. Now suppose in place of 4 volt, it is 7.5 volt. What will be the answers to all these questions? 7.5 volt in place of 4 volt. Let's discuss again one by one. What would be VA? Now, that should be quick answers. Yes, tell me, what is VA now? Yes. So, that's fine. Now, next question is, what is going to be VC now? Okay, it is not connected anymore. We are discussing from the beginning. VC minus 1.56, 7.5 volt drop, yes. It has to be minus 1.5, minus 1.5, 6 minus 1.5. Then next question was, yes, where is D located? Where is D located now? This is actually tricky. I think this should make a good assignment question. But I will give you some clue. I will give you some clue. So your assignment question is, you have to tell the new position of D. Okay, and what clue I am going to give you is this. Let's go to our discussion of potentiometer. Yes. The basic philosophy is that you are going to slide this and you are going to get some point where the potential here is equal to potential there. So galvanometer shows no deflection. Okay? This point and this point, they are at the same potential. Just imagine this fellow is part of some external circuit. Just imagine that potential here is extremely high. Maybe this potential difference from beginning till the very end is 50 volts, and here it is let's say 200 volts. If the whole thing is smaller than this, how can you ever find a point J? Suppose between these two it is much more than what it is between these two. Between J and this point, potential difference is smaller than potential difference across the whole. So if this is too much more than from here to there, there is no question of this experiment being successful. You should choose your battery here smartly to make it successful. Your potential difference from here to here, let's say this is higher, this is lower, then from here to here should be more than the potential difference from here to here for the success of this experiment. So that is a hint, and I expect answer via assignment. So I see a private message, but I would expect you to write whatever you want to write via assignment system. Okay? So let me put this screen back, board number 5. And we stop at this point.